Hey, this is a video for 9.6, ocean warming. So go ahead and check out the overview and set up your guided notes. So just to review, the specific heat is the amount of heat that an object will absorb without changing temperature. In other words, another way of saying it, it's the amount of energy that it takes to raise an object's temperature 1 degree Celsius. So for metals, compared with water, metals have a much lower specific heat. If it obtains or absorbs the same amount of energy as a similar amount of water, it will increase the metal's temperature much greater than it would increase the temperature of the water. That's because the water is absorbing all of that heat energy without actually raising the temperature of the water itself. Now that's a good thing for water, but it's also a bad thing when it comes to our environment. When water absorbs energy and it raises in temperature, it's really hard to cool it back down again. And we saw this in between 2013 and 2016. We had some retreating sea ice in the Arctic area that was really close to being completely free of sea ice. If you see this animation over the course of that time from 2013 to 2016, the sea ice really retreated. It didn't completely disappear in the summer, but it was, pretty close. Now, a couple of things is we can open up shipping lanes, but that's not the human benefit that we really want from this. We are running the risk of opening up an area to some solar energy. And once that happens, the sea ice has the highest albedo on the planet, but the ocean actually has the lowest albedo. It will absorb a lot of this energy. It is a really dark surface when you look at it. So it's going to absorb the most solar energy. And that also the heat in the atmosphere, any sort of heat that is caused by the greenhouse effect from global warming, it's going to be transferred to the ocean. So the ocean, 90% of all the warming is occurring in the ocean. And most of our Earth's surface is covered by ocean. And also the oceans are so incredibly deep. There is such a large amount of water that is present. That is a lot of heat that can start cooking our planet, basically. So the warm ocean is holding all of this excess heat that is being stored in our planet. Again, a lot of it is a lot of the solar energy is not reflected back out into the atmosphere or back out into space. So it is increasing the temperature of the items or the objects that it hits. So the warm ocean heat is going to radiate it back into the atmosphere, and then that's going to cause other areas to warm as well. Now, this is affecting the thermohaline circulation. The thermohaline circulation is shallow warm currents and deep cooler currents that's basically moving the water around in the ocean. But with the heating of the Arctic regions, in fact, areas on our planet that are warming the fastest are the Arctic regions. And there's an area up here in Northern Europe that's actually, getting cooler. Now, the reason for that is because a lot of this ice is melting in Greenland. A lot of the polar ice is melting, and that is flowing down south, and the fresh water is less dense, so it's not sinking to the bottom. So this cool water, or when these warm currents flow up, they're cooling, sinking down to the bottom, and then they're flowing back south, where somewhere around the equatorial regions that warm up and rise up to the surface and continue this process. But this is becoming disrupted because of this added increase of fresh water. So if the thermohaline circulation were to be just cut off completely, we would have long standing climate shifts in our planet. And that would be very detrimental to our life and to biodiversity in general. Again, because this warm air this warm water is not flowing as strongly up, we are finding out that it is getting cooler up here because it is not having the warming effect from these oceanic currents. So just a reminder again, a review of hypoxia. When we have warmer water, cool water holds more oxygen, warm water holds less oxygen. When the oceans become warmer, it will be more difficult for fish to survive, especially because the warmer water is going to mean that they have higher metabolisms, which means they're going to have a higher oxygen demand. So there's not going to be enough oxygen to support the populations of fish. Now, migrations are also going to be impacted. We have these areas around the world that are famous feeding grounds, and these are based on temperature. So at certain times, there might be, maybe in the spring or in the summer, there's different times when different fish, different phytoplankton or zooplankton may be present. And this is drawing animals there, and it's been drawing them there for millennia. And then what they will do is they will move somewhere else for their breeding grounds. Now, their migratory routes, this is shown in yellow, but all of this is related to temperature. So when you're changing the temperature of the ocean and you're altering the ocean currents, you're really impacting the presence or absence of these animal or plant species. So you're impacting migration, you're impacting feeding and breeding of many ocean organisms. One in particular is coral. Remember that coral has a very narrow range of tolerance. It is a symbiotic relationship between an algae and an animal. The coral polyp has algae living in its tissues, and the algae are photosynthetic, and that provides the color for the coral. And then the coral secretes a calcium carbonate skeleton that protects it, and it protects the algae. So what happens when coral get distressed, they will release this algae. And while it is technically possible to get the algae back, it takes a very, very long time, and it takes really pristine conditions for these coral to take on this algae again. So once coral is bleached, it pretty much is dead. Now, coral are affected by warming oceans because that causes thermal stress, and that thermal stress can lead to coral bleaching, can also lead to other diseases of the entire reef. So you may see entire reefs because one coral builds a skeleton, and all the coral, even though it seems like they're separate individuals, but it's just basically one giant colony. So when the sea levels are rising, from warming oceans, from melting ice caps, from melting glaciers, when sea levels are rising, also from thermal expansion, you may have sedimentation that is present, and that can smother the coral. Storm patterns are going to be altered. You're going to have stronger storms, and this can damage the structure of the coral, opening it up to different diseases, but also opening it up to predation from particular fish. Like the parrotfish likes to eat coral, and if you expose this structure, like more fish may begin to damage the structure of the coral reef. If precipitation is changed, you're going to affect runoff. And if runoff is coming from an area that is rich in nutrients, it can lead to algal blooms, which can lead to an eventual hypoxic condition. If you're altering the currents in the ocean, you can have changes in temperature that may change migratory patterns of zooplankton, of phytoplankton. It can mean less food for the coral. And finally, with ocean acidification, you're having a reduction in pH, and that can reduce or weaken the calcium carbonate skeletons. This is an example of a coral reef before and after bleaching. Here's what happens. Once it is bleached, it is really difficult to get the algae back into this symbiotic relationship with the coral. So what I would like you to do is respond to this check for understanding. And for FRQ practice, I want you to describe an impact of climate change on coral reef ecosystems. I hope that this video is informative. I thank you for your attention, and I will see you soon.